Okay guys, page 141 here, we're looking at skew lines. So I want to make a triangle here. Now it doesn't matter which lines I choose to do this with, but I want to go parallel from one line, parallel to CD. I'm going to pick CD. So I'm going to go parallel to CD from B, and then horizontal from A. Now that's giving me a triangle here now, ABX in elevation. Now I want to do the same then in plan. I want to go parallel to CD through B. So parallel to CD from B. And I'm going to be coming down then from X, or to find X in plan. And that gives me a line here on plan then, XA. Now, I'm going to color XA in green here, just to kind of help you understand this. Now, XA has some important features about it. Because it's parallel in elevation, it's a true length in plan, and when I look along this, it's going to give me this. XA will be a point view, but it's going to give me the skew lines as parallel lines. Now we're going to see this in a second. So I'll just set up so I'm going to project them up C, A, D and B. Now I'm going to drop some perpendiculars or some verticals here to take some heights. Because we're projecting from plan last XY line back for the distances. So D is not much. That's A and this is C. So C was the tallest, then A, D was the lowest, so that must be B. And what I should have here now, I'm going to go parallel through the long one first, is there is CD. Here is AB. So they are perfectly parallel there now for starters. So now I'm going to just set up another XY line here. And I'm going to project these out and just set up that angle here now. So again, I'm projecting from here, last XY line back. So that's my XY1, XY2. So A is the closest. Then C. B is the farthest. So I'll just adjust that there now a bit. And D. So we'll join them up. There's D, C, A, so this is B. So here is CD. Here's AB. Now the shortest perpendicular distance between them is here. So I want to project that back. So I'll just get a color here now, I think, to do that in. Okay. So just project that back. So that there. Projecting that back. And now to get this information from here back to here, I could project, and I suppose I will project, or I could take heights from here and step them up to the front view as well, to the elevation. But so this is on CD, so I'll just put a few lines there just so you can see where they're coming from. So now sometimes they're just in terms of accuracy. It's easy to be a little bit off, but I could have taken this distance here because, and I could have, or sorry, I could have taken these distances here now, and those distances are heights. So I know that it's this height on CD. So I'm just going to mark that up there and go across. So it's that height on CD, and it is at this height on AB, and just step that up there. So it's at that height on AB. So this here. Now, looking at that there, now they don't seem to line up. Now the CDs are pretty perfect, but, and that's the danger with bringing, because if I brought this point down now on AB, it really should be here, and that is where the right answer is. But you can see when I'm projecting this down here, and I'll just set this up, when I'm projecting this down here onto lines that are sort of running close to parallel like this, so when I brought A down from here, it's very hard to see where does it actually cross, and see it really should have been down here, but it's very hard to do that. So that's why sometimes, you know, if you transfer heights, it can give you a more accurate location for that. So I just need to rub that Tipex that out there now in a second. So it's not that it's actually wrong or anything, but it's just a tiny bit inaccurate. So I'll just leave that there and we'll move on to the second one. Now this one, the key thing here is that this is looking for the shortest horizontal distance. Alright, so same strategy again. I want to go parallel to one line from the end of the other, so I'm going to choose AB, and it doesn't matter, I'm going to bring parallel to AB from C and horizontal. I'm going to put this in green again just to highlight this. So we're after making a triangle, but DX is horizontal. So I'm going to bring X down, and I want to do the same parallel again. So parallel to AB from through C. But no matter what line you choose to work from or parallel to, it always works out giving you the same angle. So here is X, and X to D is the angle I'm looking for. So if I look along DX there now, it's going to give me the skew lines appearing parallel. And if you experiment with other lines, you don't have to copy whatever I've done there. It'll still work out giving you this angle. So we want to look at this angle. Project them out. Put on an XY line. Now these should be parallel. So that's XY1. Projecting from plane, last XY line back. So drop a few verticals here just to measure accurately from. So B and A. C and D. Now I would join the long one first. Okay, so this is B, A is the highest, C and D, but I would join the long one first because that's probably the more accurate one, and then go parallel through the shorter one. That's working out perfect anyway. Now the thing that's different about this, if we wanted the shortest distance, we'd be looking perpendicular to them. But we want the shortest horizontal distance, so we need to look along the ground, which is horizontal. So we're going to look along the ground. So this is the angle of the ground here. So I want to look at that angle. So will I project down or up there? I think I'll project down. Now I'll adjust that camera in a second there now to make sure that you can see. So there's our angles down. I probably could have gone up as well. Anyway, it'll be alright. So here's my XY line. XY, XY2. So I'm projecting from here, last XY line, back. So B. There's C. Here's D. And here's A. So when I join these here now, so here's AB, CD, now this is the shortest horizontal distance, so I want to get that information back there now as best I can. So when I project that back, it is here. Now, what's a smart thing to notice here now, I'll put this in, but because this is a horizontal distance, if I take the height here, I'm getting that is like 48, say 47.5, 48 above the ground. That is the height of that horizontal line. I'm going to step that height up here because when we were getting these, we were taking our distances from the front view, like there's B, and marking it up there to get B. So I can take the height of this, which is, I was saying it's around 48. I'm going to just step it up here. And that there is the shortest horizontal distance. Now you will notice, oh God, that it's right here. So it's practically where they're crossing now. It would not necessarily have to be like that. And so that didn't really, well, I suppose it helped us to not be inaccurate, because when I project these back now, we'll see how it works out. So it's here on AB and here on CD. So I'm getting that it's from here to there. But you can see there now, because it's the same thing as we had in the first question there. I know that in reality it needs to be all very compacted. So down here it's almost like a vertical line. Yeah, that looks okay. It's not quite vertical, but when you bring it up, you can see, you know, it's all very compacted here. So that there is our shortest horizontal distance. So that's 2 done. So I just realized there now, guys, I just realized that I was going off camera there for a bit. So I'll just zoom back out of that. So when I looked parallel to the ground here, they crossed, and I brought that back. And then I took that height up to here and brought it back down. But yeah, the key thing here for the shortest horizontal is I was looking parallel to the ground for them. Okay, so this one is looking for the shortest 45-degree distance between them. So the same thing again. Going to go parallel to, it doesn't matter, but I'll just pick CD. and horizontal from A. So that is X. Again, going to put that in color because it's the horizontal line that we want in plan. So let's bring X down. Do the same parallel. So I want to go parallel to CD from B. So parallel to CD. Okay, so AX is our green line. So I'm going to just project out there. So here's our XY line. And I just need to bring C. So these lines should appear parallel. So the usual there, just drop these verticals. So A is only about 5 mil. So C, B, D. So there's CD. There's AB. Now I will go to the border though of making sure that they are parallel to each other. So there's your angle. Slide along, just make sure that they are parallel. Now finally, this time we want to look at an angle of 45 degrees to the horizontal plane here now. So I could just use the protractor here, I suppose, to get my angle. So 45 degrees to there, that's my angle to look. So I'll just set that up here now. That's looking 45 degrees. So the usual, projecting from here, last XY line back. Now I could use a datum here to reduce the amount of space, maybe I will. So I'm just going to put a parallel XY line. Instead of projecting or taking my distance from here, I'm going to move that back through B. So I just put it in green here. So you can see I'm going to call that's called a datum. So now B is 0 distance. So it just reduces this amount of all of them, but it won't change our answer at all. So that's D. There's a C. So join them up. Here's AB. Here's CD. Okay, so that's the closest 45 degrees, so I need to project that back. So and just project along again then. So here's my angle for projection, so it's here on AB, here on CD, and I'll put this in red, I think. I'll just mark the dots anyway. So getting that it's here on that one and here on this one. No, so I could just project them back up. So I'm getting this on CD and this one on AB. But again, the other way I could do that is we know the height on AB is this much. So I'm just double checking that, and it's giving me the same thing yet. And the height on CD is that much. Just check that across, and that's the same, yeah, so that's it. And AB is low. Interestingly here, we'll just check this out now. I wouldn't expect this to be perfect now, but if I made a cone out of this, so I left the bottom point where it is and I spun the top one around, and if I make a cone out of that line here in elevation, it should be a 45-degree cone, because that line is meant to be a 45-degree angle. So if I just make a cone out of this quickly and just test it and see if it is accurate. So 44 degrees set square. Yep. Absolutely. Love the little guy. So yeah, the other side's small bit inaccurate, right? But alright, so that there is our, but again the key here, when you read the question, and this is the thing to understand, this one wanted 45 degrees to the horizontal plane, so that's why we looked at an angle of 45 degrees here, whereas this one up here they asked for horizontal, so we looked, this angle was horizontal, it's parallel to that, and in this one they wanted just the shortest distance between them. So when I got out here, when we got our angle, we just looked, when we got our skew lines, we just looked perpendicular to them. Okay, and that's basically everything that you need to know, I would think, on skew lines, if you understand what's done there. So best of luck with that.